This is an example of an application problem that we did in Chapter 7. And here we have the choice between two jobs. So in this particular example, we have two jobs that offer different things. Job A, for example, offers to pay 10% of commission of sales. So for example, if you as a salesman sell $1,000 worth of merchandise for the company, then you'll receive 10% of it, which is $100. If you sell $10,000 worth of merchandise, then you'll receive 10% of that, which is $1,000. Job B, on the other hand, is offering you something a little bit different. It's offering you to pay you 5% of commission, but even though it's a little bit lower than the 10% of commission of sales on Job A, it's offering you something extra. It's offering you $600 per week of salary on top of the 5% commission. So it's a little bit tempting to choose one over the other one for some people, but only through with the use of mathematics can we find out at the end what choice of job is better for you. So we're going to graph what's going on with both of these jobs. Okay, so job A is a curve that starts at 0 and it rises up. The more you sell, the more you make. That's just pure commission. Now, job B, as indicated by the curve, it starts at a little bit. It doesn't start at 0. It starts higher. It starts at 600, and it rises, but it doesn't rise as quickly as job A does. So at some point there's an intersection that takes place, and it is at that intersection where both jobs will pay you the same according to the sales that you have, that you make. So we're going to take both of these jobs and write an equation for them. Job A, the equation for that is y is equal to 10% times x. So once again, that is indicating that if you sell $1,000 worth of merchandise, you multiply 1,000 times 10%, and you earn just $100, 10% of the 1,000, and that's all that you will get. I'm using the variable y to represent the money earned. And choice B, or job B, is 5%, so 5% times the total sales, which I'm indicating with the variable x, plus the salary of 600, which in our case would be C in the equation that I have on top. So if you notice these two equations, they're both I'm setting both equal to y, and I'm finding the point where they pay the same. So that's why I'm using the same variable y for job A as I am for job B. The money earned would be the same for both. So if that's the case, I can do a simple substitution. Since y is equal to 0.10x, I can simply substitute that 0.10x into the y in the bottom equation. And after I do that, there's the problem that I have to solve, or there's the equation that I have to solve. And once again, notice that I didn't use the percents per se, but I did use the decimal representations for the percents. So I will solve this equation, and I get a value of x of $12,000. Now remember at the top of the picture here, the screen here, I'm using X to represent sales, or the merchandise sold, and it's important to be able to interpret the results that you get back into the context of what's going on in within the real world here, back to the context of the jobs. So X is equal to 12,000. It's indicating that at $12,000 in sales, both of the jobs pay the same, and now you can make a decision. If you know, for example, that you're a pretty good salesman and are going to be able to sell more than $12,000 worth of merchandise, then you would be better off by choosing job A, since to the right of the point of intersection, the curve on A is a little bit higher than the curve B. However, if you feel like you're not going to do as well a job as with the sales and sell less than 12,000, then you're going to be to the left of the point of intersection, in which the curve B is a little bit higher than the curve for A, and you would be better off choosing job B. And that is it.